Let's evaluate each one of these expressions. So in number 4 here, negative 7 to the 0, that's 1, right? Because we're using this rule, x to the 0 is equal to 1 as long as x itself is not 0. So our base, right, this x is the base. So look at this rule. The base, not 0. The base is any number other than 0. So if you raise a non-zero number to the 0 power, you get 1. We have a non-zero number to the 0 power, so this is 1. Now what about this one? This is a little bit different. This is negative 7 to the 0. Now in this case, the 0 applies only to the 7, not the negative. If it was the negative, it would look like this one here. So what we get in this case is negative 7 to the 0 is 1. And what about this one here? Now we get, all right, let's look at this. What we're getting here is negative 7 to the 0. Here's the negative, and then this part right here, that's a 1. So we get a 1, a negative 1, and a negative 1. In number 5, we've got negative 2 to the 0 plus 2 to the 0. Now, a non-zero number to the 0 power is a 1, plus 2 to the 0 is a 1, so this comes out to be 2. In number 6, we've got 0 to the 2, 2 to the 0. Now, be careful here. The top number is just 0 squared. That's 0 times 0, which is 0. And the bottom number is 2 to the 0. So 2 to the 0, that's 1. As long as you don't have 0 in the base and you have 0 in the exponent, we're going to get a 1 out of this. So we get 0 over 1, which is, now 0 in the numerator is okay, not the denominator, that's undefined. So 0 squared over 2 to the 0 is 0 over 1, which is 1. And in number 7, we have 6 to the negative 2. We can rewrite that as 6 over positive 2, right? Our rule says we can change the sign of an exponent from negative to positive if we change the position of the base. So this base 6 goes from the numerator down to the denominator. And then actually this is small enough, we can even write this as 1 over 36.